Welcome back, everybody, to another deep dive. This time, we're looking at something pretty cool, actually, AI, and how it's kind of like shaking things up in the world of competitive programming.
Yeah, it's a pretty fascinating area.
Yeah.
A lot going on.
Like, imagine those coding competitions like, CodeForces and the International Olympiad in Informatics, like the IOI.
Yeah, the IOI.
And you got these algorithms battling it out. It's like wild, right?
It is. And we've got some awesome research papers from OpenAI on their large reasoning models, or LRMs.
Oh, yeah.
We'll dive into those as well as a couple of other articles that we found.
Yeah, and to help us kind of break it all down, we got 5 key questions that I think are going to really help us understand how this whole thing works.
Yeah, definitely.
All right, so first things first, what exactly are these large reasoning models, or LRMs? And how are they different from those large language models, LLMs, like the ones that we use every day, like ChatGPT?
So yeah, that's a good question to start with. Think of LLMs like ChatGPT as masters of language. Okay. So they're really good at predicting the next word in a sentence, generating text that sounds like a human wrote it, things like translating languages, and even writing different kinds of creative content. But their strength really lies in pattern recognition within text.
Gotcha.
LRMs, on the other hand, are designed to be really good at logical reasoning.
So it's not just about spitting out words.
Right.
It's about actually understanding the logic behind the code.
Yeah. Yeah, exactly.
Okay.
So these LRMs, like OpenAI's models O1 and O3, they use a process called chain of thought reasoning.
Okay.
And it's basically they're thinking step by step. They break down a problem into smaller parts, just like a human programmer would.
Oh, that's interesting. So, if I'm getting this right, it's the difference between just knowing the alphabet and then actually being able to write a story.
Yeah, that's a really good analogy.
Okay.
And then the way that they're trained is fascinating too. So they go through a process called reinforcement learning, where they get better at making these logical connections and writing code that actually works and solving those challenging coding problems.
So they're learning by doing.
Yeah,
just like we do.
Exactly, yeah.
I like it. Okay, so question number 2.
Yeah.
How good are these LRMs actually at competitive programming? Did they actually stand a chance against human programmers?
So OpenAI actually tested these models on CodeForces.
Okay.
Which is a platform, known for its fierce coding challenges.
Yeah, it's no joke. It attracts some of the most talented programmers.
It does.
From around the world.
Yeah, and you won't believe this, but their model, O3, got a rating that puts it in the 99.8th percentile.
Oh, wow.
That means it's performing with the elite, the very top competitive programmers around the world.
That's insane. So we're not just talking about a fun experiment here.
Right.
These systems are solving problems that even really good programmers would find difficult.
Yeah. They're solving problems that you need a deep understanding of algorithms, data structures, and really just how to think strategically. They're optimizing routes, sorting tons of data, and predicting complex patterns.
That's wild. Okay, so OpenAI also created a special system, O1IOI.
Yes.
Specifically for the International Olympiad in Informatics, the IOI.
Right.
It's the Olympics of coding, right?
It is. It's known for its insanely hard problems and really just pushing the boundaries of how you think about algorithms. And that brings us to our third question.
Yeah.
How did specialized training and strategies play a role in getting this O1IOI ready for this coding showdown?
Yeah, because I'm super curious about this, because the IOI is notoriously hard.
It is.
What did they do to actually get the AI ready for that kind of competition?
So they started with O1, the base model, and they gave it some pretty intense training.
Okay.
Designed to really sharpen its skills for the IOI. Like training an athlete for a specific sport. They gave it tons of really tough coding problems and even trained it to format the solutions exactly how the IOI wants them.
So making sure the AI understands the rules of the game, so to speak?
Precisely, yeah.
Okay.
But they didn't just stop there. They actually equipped O1IOI with this test time strategy,
Okay.
which is basically a set of rules and guidelines to pick the best solution.
So almost like having a coach in the corner, giving advice during the competition. So how did it actually do? Did it win?
So it didn't get the gold.
Yeah.
But it got a crazy good score. With the official submission limit of 50 tries, it got 213 points.
Okay.
Which is just above what you need for a gold medal. And get this, when they let it have 10,000 submissions, it actually got to 362.14 points.
Oh, wow. So it would have gotten the gold if it had more tries.
Exactly, yeah.
Okay, so this is where my mind is blown. OpenAI's later model, O3, actually did better than the special O1 IOA system at the IOI without needing any help.
You're totally right, and that leads us to our next big question.
How did O3 manage to do that?
Yeah.
It shows a big leap forward in what AI can learn.
Tell me everything.
Remember how O1 IOA had that test time strategy?
Yeah, like the coach whispering tips?
Yeah, exactly. Well, O3 didn't have that. Just through learning, it learned how to develop and execute its own strategy, all on its own.
Wait, so it wasn't just following a script, it was figuring things out, coming up with its own plan to solve these like crazy hard problems.
Yeah, you got it.
Oh my God.
It's like a student going from memorizing formulas to really understanding the concept and applying that knowledge to solve new problems.
Okay, that is amazing. So like, give me an example. How do we know it's coming up with its own strategies?
So here's one interesting example. Imagine it's working on a really hard problem.
Okay.
First, it would write a very basic, like brute force solution.
Okay.
One that might not be elegant, but you know for sure it'll be correct. Then, it would use that solution to double-check the output of its more complex solution. So it's like fact-checking itself using a method it knows works. It's so smart. Like it has a backup plan in case the fancy solution messes up.
Exactly. This self-validation lets O3 spot errors and make sure its answers are reliable.
Wow.
It's a big step toward AI systems that can think for themselves more.
That is amazing.
Yeah.
Okay, so we've seen that O3 can compete with the best human programmers on platforms like CodeForces and even do really well at the IOI.
Right.
All without any help. But here's the big question. Does all this mean anything for real-world software engineering?
That's the ultimate question, because competitive programming is like a sport for your brain. It's all about solving these abstract problems within very strict rules. Real-world software development is a completely different animal.
Totally. It's messy and collaborative. And you often have to tackle problems that are kind of all over the place. So can these LLMs really handle building software that people use every day?
So OpenAI wanted to find that out, and that's question number 5. How do these LLMs do on real-world software development tasks? They tested their models on 2 data sets, HackerRank Astra and SWE Bench Verified. These were designed to mimic the challenges of real software development.
Okay, so no more like perfect little puzzles.
Right.
Now we see if these AI systems can actually build stuff in a real coding environment.
Exactly. Think about tasks like building a feature for a web app or debugging some crazy code.
All right, I'm ready. Did their skills hold up?
So let's start with HackerRank Astra.
Okay.
This one is unique because it's all about problem solving inside a bigger project, just like a real job.
No.
And there are no public test cases, so the models couldn't use those strategies we talked about.
So it's like a way truer test
It is.
of their ability to understand the problem,
Yeah,
come up with a solution, and write code that actually works.
exactly. And the results are really good.
Okay.
The earlier model, O1 Preview, already showed big improvement compared to GPT-4. It shows the advantage of that chain of thought reasoning.
So thinking step by step really is paying off.
Yeah. And when they tested O1, the one that learned even more, it got a pass at one rate of 63.92%.
Wait, hold on. Pass at 1? What's that?
It means the probability of it finishing the task on the first try,
Oh.
without needing to try again. So O1 was solving these real coding problems on the first try over 60% of the time.
That's pretty amazing. But what about SWE Bench Verified? How do they do on that?
So SW Bench Verified is interesting because it's like a smaller part of the SWE Bench dataset,
Okay.
but it's been checked by humans to make sure it's like real software engineering work.
Yeah, okay.
OpenAI tested both O1 and an early version of O3 on this dataset.
How does they do?
They did even better. O1 had a 48.9% success rate on SW Bench Verified.
Okay.
But O3, the one with way more compute power,
Yeah.
well, it completely crushed it with a 71.7% success rate.
Wait, so O3 is solving over 70% of these real-world software engineering problems.
Yeah,
That's insane. Is AI getting that good at coding?
it is.
Yeah.
And it gets even better. They also saw that O3's code was often nicer looking and more efficient than the code the earlier models made.
So it's not just about getting it done, it's about doing it well, you know?
Yeah.
Like a real programmer.
Yeah, exactly. And that's why this research is so important.
Yeah.
We're seeing AI not just competing in coding challenges, but actually being able to help build real software.
That's a game changer. Imagine if AI could help us build software faster, better, and with fewer bugs.
It's pretty incredible. And the coolest thing is that O3 didn't need special training for each task. It just learned how to adapt, to come up with its own solutions, and apply them to all kinds of challenges.
So this isn't just brute force memorization. It's like a whole new level of AI understanding, reasoning, and adapting.
Totally.
This feels like a turning point.
It really does. It seems like we're moving beyond AI systems that are good at one thing to a more general kind of intelligence.
All right, before we go too far, let's take a step back.
Yeah.
What does all of this mean for the future of coding? Like, for real?
That's the big question.
It is.
And we'll get into that in our next part. So we've seen what these large reasoning models can do with code, but what does it all mean for the future of software development? And even, for all of us?
Yeah, that's the big question, right? Like, it's super cool to see AI tackling these tough problems, but it also kind of makes you wonder about like what happens to human programmers.
Yeah, it's only natural to think about that. Like, will AI just completely replace human programmers? It's a valid concern for sure, but I think it's important to remember that software development isn't just about, typing code.
Right. It's like about understanding what people need and then like solving problems creatively and building systems that are easy to use and ethical.
Exactly. And those are the areas where human ingenuity still really matters. Like, imagine designing a user interface for an app that is both beautiful and intuitive, or figuring out the ethical implications of using AI to, diagnose medical conditions. Those are challenges that need more than just technical expertise. You need empathy, intuition, a deep understanding of how people think and behave.
So you're saying that AI is more likely to like help human programmers rather than replace them completely? Phew, that's a relief.
Yeah, that's what I see happening, at least in the near future. Picture a world where AI is like your coding assistant. It helps you with those repetitive tasks, like writing boilerplate code, spotting potential bugs, or suggesting ways to make your code more efficient.
Okay. Yeah, I could see that.
That would free up human programmers to focus on the more creative and strategic parts of development, the stuff that really needs that human touch.
I like that idea. It's like having an AI apprentice doing the boring stuff so you can focus on the big picture.
Yeah.
But even if AI doesn't like totally take over programming jobs, it's still going to have a big impact on the job market, right?
Absolutely. No doubt about it. Just like we've seen automation change other industries, AI is going to transform software development. We might see certain programming skills become more valuable while others become less so. There will probably be more emphasis on things that complement AI, like system design, complex problem solving, and ethical reasoning.
So basically, we got to adapt to the changing times and learn the skills that will be in demand. It's a wake-up call for programmers to stay ahead of the game.
It is. But let's not forget about the good stuff. How could AI actually improve software development?
And now you're talking fewer all-nighters fixing bugs, maybe.
Yeah, definitely fewer bugs. Imagine AI helping with code reviews, catching errors before they even make it into production. We could have more reliable and secure software, especially in important areas like healthcare, finance, and transportation.
Oh yeah, true. Like in those areas, you really can't afford to have software glitches.
Exactly. And think about how much faster development could be. AI could automate certain tasks, like generating the basic structure of a web application or quickly prototyping new features without having to write every single line of code from scratch.
That would be incredible. It would give programmers so much more time to focus on the innovative parts of their work.
Right. And here's another exciting possibility. AI could make it easier for people who aren't coding experts to build software.
Oh wow, explain that.
Imagine tools that let anyone with an idea turn that idea into a working app or website.
That's awesome. So anyone could create their own solutions without needing a whole team of developers. That opens up a ton of possibilities.
It really does. But like with any powerful technology, we got to be careful about the potential downsides and approach this stuff cautiously.
Yeah, for sure. It can't all be good. We need to talk about the risks too. What are some things we should be watching out for as we head into this new territory?
Well, security is a big one. As AI gets more involved in writing code, we need to be extra careful about vulnerabilities that hackers could exploit.
Makes sense. If AI can write good code, it could also write bad code, right?
Exactly. We need strong security measures to prevent AI from being used to create malware or hack into systems. It's a tough challenge, but we can't ignore it.
So it's all about finding that balance.
Yeah.
We want to use the power of AI, but we also want to make sure it's used safely and ethically.
Exactly. And that's a responsibility that we all share. AI, developers, policymakers, educators, everyone. We need to have open conversations about AI, the good and the bad, to make sure this technology helps us, not hurts us.
I like that. Okay, but let's shift gears a bit for a second. Our sources talk about using these large reasoning models for more than just coding. What are some other areas where this tech could have a big impact?
Now things are getting really interesting. If AI can reason and solve problems in the world of coding, think about what it could do in other fields that need complex problem solving, like scientific research or medical diagnosis or even legal analysis.
Yeah, that's true. I can see AI helping scientists discover new cures for diseases, or helping doctors make better diagnoses, or even helping lawyers build stronger legal cases. The possibilities are endless.
They really are. And we're only just starting to explore what AI can do with this new ability to reason. But as we venture into these new areas, we need to be careful and always think about the ethical implications.
Absolutely. We need to make sure AI is used for good to help us create a better world for everyone.
Couldn't have said it better myself. And speaking of creating a better world, that leads us to another important aspect of this conversation, the potential impact of all of this on society.
Right. We can't just focus on the cool tech stuff. We need to think about the bigger picture. How will this affect society as a whole?
Exactly. And that's what we'll dive into in our next part. We'll explore the social and ethical implications of AI-powered coding and what it might mean for the future of work education and our everyday lives.
Sounds like a plan. Stay tuned, everyone, because we're about to go even deeper. So we've been talking a lot about these large reasoning models and how they're changing the world of coding. But as we kind of wrap things up here, I'm thinking about, the bigger picture. What does all of this mean for society?
Yeah, it's really important to think about how these advancements will affect us all, not just in the world of software, but how might AI-powered coding change the way we work, learn, and just live our lives?
Exactly. What does this mean for the future of work? We talked about how AI could help programmers, but what about everyone else?
Yeah, that's a huge question, and we're just starting to figure it out. As AI systems get even smarter, they're probably going to impact a lot of different industries. Maybe automating tasks that used to need human intelligence.
So it's not just programmers who need to adapt. It sounds like we all need to be thinking about how AI might change our jobs and the skills we need to succeed.
Yeah, we need to be flexible and always be learning new things to stay ahead of the curve. It's even possible we'll see brand new jobs that we can't even imagine right now.
It's exciting and kind of scary at the same time, right?
Mm-hmm.
We're on the edge of a huge technological shift, and no one knows exactly what's going to happen.
That's true. But throughout history, new technology has always shaken things up, creating new opportunities and making some old ones obsolete. The key is to be ready for change and prepare ourselves for the future.
So how do we do that? How do we get ready for a world where AI is everywhere?
Education is going to be key. We need to teach kids how to think critically, solve problems, be creative, and really understand technology. Those skills will be super important in a future driven by AI.
So it's not just about memorizing facts anymore.
Right. We need to raise a generation of kids who are adaptable, innovative, and ethical. Kids who can use AI for good.
I love that. But it's not just about education, right? We also have to talk about ethics. How can we make sure this technology is used responsibly and for the benefit of all of humanity?
Absolutely. We need to set clear rules and guidelines for how AI is developed and used. We need transparency, accountability, and fairness. And we need to talk openly about the potential risks and benefits of AI and make sure everyone has a voice in shaping its future.
It sounds like we all need to be informed, involved, and proactive in shaping the future of AI.
Exactly. We can't just sit back and watch. We need to be active participants in making sure AI is developed in a way that aligns with our values.
This deep dive has been amazing. It's incredible to see what these large reasoning models can do and how much they could change our world.
It's been a really fascinating journey. And remember, this is just the beginning. The field of AI is constantly moving forward with new discoveries happening all the time.
Yeah, it's a pretty exciting time to be alive. But as we move forward, we got to be thoughtful, embrace the good stuff, but also be aware of the challenges.
Totally. We encourage everyone to check out the sources we mentioned and keep learning about this incredible and rapidly evolving field.
Well, that's it for this deep dive, folks. Until next time, keep exploring, keep asking questions, and keep learning. The future is full of possibilities, and it's up to us to shape it.